Hello and welcome back to Calculus 3, section 11.6 on calculus of vector-valued functions. So, here is the whole lecture. Do calculus term-wise. Done. Do it term-wise. That's it. And now 11.7, right? So what do we have as our vector-valued function? We have a collection of three functions, f of t, g of t, and h of t. Calculus consists of limits, derivatives, and integrals. So you just apply those concepts of each one of those functions, and that's it. So if you know Calculus 1, well, this section is over for you. If you don't know Calc 1 well, you actually study Calc 1. So, vector r of t is called a vector-valued function because we have f of t, g of t, and h of t. The limit of r of t as, let's say, point P goes to point P0 is going to be the vector of, so limit of f of t, limit of g of t, and the limit of h of t as x goes to x0, y goes to y0, z goes to z0, right? So you just apply the function, the limit to each of the function. The derivative of vector-valued function is going to be the f dt, the g dt, the h dt. And finally, the integral of vector-valued function dt is going to be the integral of f dt, integral of g dt, and integral of h dt. So this is what I meant by do it term-wise. You just apply the calculus to each member of the vector-valued function independently. You are technically solving 3 Calculus 1 problems every time you have to do this. So that's that. Now obviously all of our examples are Calculus 1 examples. So let r of t be t squared minus 1 e to the negative t and sine t. There we go. So find the limit as t goes to 0 of r of t. So it's the limit of t squared minus 1. That's the limit of e to the negative t. And that's the limit of sine of t as t goes to 0. So the first one will be negative 1, the second one will be positive 1, and the last one will be 0. So that's the limit. I just did 3 separate Calculus 1 limits from chapter 2. If I want to make this spicier, I put something with L'Hopital's rule. That's technically what it is. The derivative of function r would be the derivative of each one of these. So I have the derivative of t squared minus 1, the derivative of e to the negative t, and the derivative of sine t. The derivative of t squared minus 1 is 2t. The derivative of e to the negative t is negative e to the negative t. And the derivative of sine of t is cosine t. And you have your derivatives.
You need to sign something too.
I need to sign?
Yeah.
All right. Did you remember to bring enough airdrop forms for everyone else?
You didn't tell me to do that.
No, I didn't.
I should have.
But if I need to sign yours, I'll have to sign all of theirs.
Yes, this is true.
That's okay. I'll go with everyone over there. The integral would be the integral of each of these. And I have the integral of t squared minus 1 dt, integral of e to the negative t dt, and integral of sine t dt. Integral of t squared minus 1 is t cubed over 3 minus t plus c1. Guys, plus c. There is plus c for each one of these. So c1 for the first one. It's not there for decoration. The next one, negative e to the negative t plus c2. And finally, integral of sine is negative cosine, thank you, plus c3. Now you can write this as 1/3 t cubed minus t e to the negative e to the negative t and negative cosine t plus c1, c2, c3 as a separate vector, and then you can write this as plus c arrow. Generally what I say to my Calc 1 students is either plus c or minus 1, right? Plus c or minus 1, minus 1 on the exam. If you miss plus c, well, over here is either plus c or minus 3. See that? 1, 2, 3. So minus 1 per. So it's more expensive in Calc 3, but then it's also, you guys had Calc 2 to practice plus c every time you integrate, so it's fair, right? The third level, so the third level of calculus, and then obviously if you miss plus c is minus 3 now. It's especially bad when the question is 5 points. So it's minus 60%. I just didn't put plus c. Yes, that's why the bridge in Florida failed, because you didn't put plus c. All right? So I'm sorry, you can never win the argument. It's the nature of the beast. These are your examples of limits, derivatives, and integrals. Apart from a funny story, this is done. Just have a funny story to say, and that's that. Questions, concerns? You know your Calc 1 and Calc 2, because if I ask for the integral of ln of x, of t, that's Calc 2, it's not Calc 1. Does anyone know what the integral of ln is? Right? Yeah. That's your Calc 2. Maybe we can review that one. So the integral of 1 over x dx is ln absolute x plus c. The integral of ln x dx is anyone remembers it?
X element.
Which you can also write this way. This is done by parts in 7.2. So you can go and figure it out. That's the only one that technically kills your grade. You are familiar with the basic ones, and generally we stay with basic ones. You are not going to see a partial fraction decomposition within trig sub, right, like in Calc 2. But you are going to see a lot of integrals that are basic U substitution. Maybe 90% are U sub, and you might see here and there by parts. So that's something to keep in mind. Obviously chain rule and product rule for your derivatives, and then limits, basic limits where you can plug stuff in, and L'Hopital's rule, 4.7 in your textbook, which is when you have the limit of 0 over 0, you take the derivatives, or infinity over infinity, you take the derivatives. So that is also something that pops up. So basic limits where you plug stuff in, L'Hopital's rule, derivatives, focusing on chain rule, product rule, and then integration, huge emphasis on U substitution, which is 5.5, and then also obviously basic ones, and then integration by parts, which is another extremely important technique. Those of you going or sitting in differential equations, partial fraction decomposition is extremely important for chapter 4. You will do inverse Laplace transforms, and then you will also have to do a lot of by parts, because the Laplace transform and other things. So technically, if you are going to differential equations, just know everything from Calc 2 and you're golden, including and especially power series. Differential equations, chapter 3, titled Solving Differential Equation Using Power Series. So if your chapter 9 is terrible, you have time to fix it, right? You have to learn your chapter 9 very well from Calc 2 to perform in that class later on. And it gets worse after that. So this lecture is over, so I'm going to say bye.